Thank you, everyone. Thank you, Vera, Dr. Vera, for the presentation and for this opportunity to present you some of the research that we're doing at UCL Center for Blockchain Technologies. This part of this research, it's enters more into the finance, computer science sides. Although today it seems a lot of interesting topics, this might touch. I will give a bit of context before I enter into what we're analyzing here, because I know we are here from different contexts and backgrounds, so to help ease in. Right. So the purpose of this research is to analyze an automated market maker versus a limited order book, and how they differentiate between the trade size executing and giving X amount of liquidity available. The motivation for this is given the broad use of the stable coins and other major tokens. Now this could facilitate the movements of money in a decentralized exchange or in something like the XRP ledger. And of course the routing of that money as it moves through the chain. Now, how do we proceed to do this analysis? Given this, to the best of my knowledge, and anyone can correct me if I'm wrong, the XRP ledger is one of the few ledgers that has a limited order book directly at the protocol level, and plus an automated market maker. So that presents an interesting and great opportunity for us to be able to compare how both venues work together at unison versus other existing layers that do not have the stack of features. And we validate this using XRP layer real trading data, and then we try to refine the routing logic to see if we can optimize it and get better results than the existing one. Now, before we enter more directly into the topics, you see the figure here on the right that says liquidity router. The idea for this is if you as a trader come and execute a trade, for example, you have your XRP token and you want to buy Ripple USD, the stable coin. And the way it's built in the XRP ledger is we'll try to find the best liquidity venue either at the limited order book or with the AMM based decentralized exchange built there. So this is just quick example logic how it could look like. It won't necessarily always tell you that the AMM is better. Sometimes it will tell you the limited order book is better. That's just for illustrative purposes. Okay, before getting to more details, so a limited order book, like the one here on the right, and the AMM here on this side. Limited order book, the way it looks is like a step ladder because that's a stack limited orders when someone does either a buy or sell in a centralized limited order book. So just for example, if you go buy in Binance, Kraken, to give you an example of centralized exchange, they use a limited order book type of system where the offers are stacked this way, either on the buy or sell side, and usually you have a market maker in the middle who makes money in the spread between both sides. Now, in the automated market maker side, here it's a funding curve where the price only changes according to each new trade being executed in the system. Right, and now bringing all this together, how this looks like in the XRP ledger. So when you go and execute a trade, you have both systems, and depending which one is better in terms of pricing, you either will be end up executing on the limited order book or in the automated market maker side. Now, there are some things that we are emphasizing here that is for, as part of our findings, given that the automated market maker uses the version of liquidity provision that they use is from zero all the way to infinitive. As far as I know, concentrated liquidity type of approaches for AMMs are not available in the XRP layer yet, but I know there is a proposal that was done like 3 weeks ago to bring something like that into the XRP layer, but for the purposes of this analysis, our focus is only in what is currently available. So right, if you see this example here, if you execute a trade and the best venue for that trade where you have the most liquidity will be the AMM side, that would mean that it will be on this side. but then you see that then the next trade, instead of executing at this price level, it will execute on R1, because the way the AMM version of the XRP layer is that it will take the fees for the trades executed, and those fees become part of the liquidity that can be used for the next trade available. Right, and we'll look at some flags. So for us, what we're trying to do is trying to see, given the current routing system in the XRP layer, if we can build something different, because this in itself becomes an optimization problem, how you can allocate the best consumption of liquidity given the available in both types of systems. So, for example, you can say that here, for the purposes of this, when we refer to X is what we're expending, and when we refer to Y is the value that we're receiving as the token from when you do the trade. So, for example, the limit order book here, you can say that for the AMM, you consume X amount of X, and then the remaining for the limit order book. This is just example, doesn't mean that we do it like that all the time in our optimization problem. Now, before jumping in the results that we find, just a quick introduction to price path finding and the XRP layer, how they work. So, the simplest path when you do a transfer of money from one user to another is this one, where you have an issuer of a token, and then you just send it to another person, and then you can make it a bit more complex. Here's when the limit order book intervenes. So this could be, for example, imagine that instead of USD, this could be like Mexican pesos. So you will have, for example, there in the order book, 2 tokens representing US dollar and representing Mexican pesos. And then you can make it more complex where, well, not complex, but imagine that there's not exact order book representing both, but rather you need the XRP in there, token as a bridge, because you only have an order book for USD with XRP, and then one order book for pesos and XRP. For this research, we focus only on this path. This is out of the scope, but just to give you a brief introduction, what exactly we're trying to analyze this with the smart routing. Yes, and this is another example, other things that can be achieved. Right, so for us, the question that we're trying to solve is, can we find a better path that they can fill across the AMM and limit order book and then produce a better pricing? So for this, we try to look at the real execution, reproduce it, and then see if we can find a better approach. So these are the different token combinations, token pairs that we looked into. Main focus was because there is considerable amount of liquidity available in the XRP layer, so that helped us to based on the amount of trades for 2 weeks, what we can find. Now, our testing is that if we keep going back to this, because if we keep, for example, $100 here, and then you started with I don't know, 1,000 Mexican pesos, how, if we keep this fixed and then try to see different combinations there, that give us this, the same amount of 100 Mexican pesos, sorry, the 100 US dollar, but require less amount of the input, and then vice versa as well. If we freeze 1,000 Mexican pesos, how much what's the path combination that can allow us to get a higher amount of US dollar on the other side? So this is pretty much it. So when I say the X, I'm referring to the token being spent, and then Y is the token that we are receiving on either side. So for this, this is the amount of transactions from real-time data that we use in order that we can do our testing. And we were able to find at least 99% of all of them, and to reproduce the path that they follow. And then as I told before, it's pretty much an optimization problem that we're dealing with. So since it's an optimization problem, our finding is that we are able to improve 38.94% of the transactions But when you look at what we actually end up improving, is considerably remote gain, is 0.01 BPS. So sorry, 1 BPS, which is 0.01 percentage. That space, that finding is pretty much based on this. This is what makes the difference. Those fees that get recomputed back into as liquidity in the AMM, that makes the difference in getting that. Right. And from that, the main improvements that we see is in getting the same output but requiring less input of the other token. And then the next one is providing the same amount of input tokens but getting more of output tokens on the other side. So mainly the main finding, as I told you, is pretty much on the fee, on the compounding side. It's pretty much because how the AMM is built currently now. So to show you one concrete example where we use the baseline of different transactions, this is the token pair, full C and XRP. You can see that at least from the optimize, it looks like we get better performance when we use the limited order book. And when we use the AMM, it's slightly less, but when you aggregate both together, it's pretty much the same results across the line. Right, and this is all from my side. Hopefully it did not go too fast, but not, please make any questions, we can clarify anything. I need to put the limitations of future work as for transparency in research. One thing that I think this could be also an opportunity for anyone who's interested in this topic. You can try to model dynamic liquidity, which is for us, we are holding liquidity constant at venues as we execute trades against it, but there might be opportunities where there are liquidity providers that come between different trades and add more liquidity into it. And of course, some reading and references for you that go into this topic in a bit more detail, but not exactly what we're trying to do in our empirical testing.
Thank you, Walter. You're raising a good point there. All these resources from all the presentations of those 2 days will be interesting to get collected. And in the new tool that we're developing, there will be a specific category where you can upload your papers and you can keep posted to everyone in the community about what you do. Are there any questions to Walter or comments? Yes.
I think a simple question. I don't understood just one side. If I buy something, I can buy or an automatic market maker or a limited order board. But if I want to buy 20K, for example, yes. Sometimes we can split this amount of money 50% on automatic market maker and 50% on the other side because the price is changing. Right. After I pay on automatic market maker, then the second part we can pay on the other side. How we can balance this payment? What happens in this case? There is you can buy 50% here and 50% here and provide us an average price. Or?
Yeah. So for that could be arbitrage. For the example I was giving is, at least for the XRP ledger, because of the price path finding, they do it all of that behind the scenes. You cannot do that exactly yourself. I mean, you can be exposed directly to their decentralized exchange and go only trade in the decentralized exchange. But if you do this, it's the algorithms themselves. So at least the purpose for this research was, given the current smart routing that they have, can we find a better allocation ourselves than trying to play between both venues? Now, I do know There's people who do arbitrage exactly by going into Binance that has that system, and then going into, for example, Uniswap B3. Sorry, this will be B2. Uniswap B2 that has this system, and since Uniswap B2 usually running, most of the people go in Ethereum, it's very slow. They use that time frame to take advantage of that. But that's a different topic, a bit outside the scope of this one, but that's if you want to do arbitrage. I know people try to do like that, but at least in the XRP layer, you don't have exactly a choice which one you want to go first with, depending on the liquidity.
Okay, thanks.